Okay, for this lab we were asked to implement a 5-bit binary multiplier. It multiplies two 5-bit binary numbers and displays the output in the 7-segment display in hexadecimal form. We were asked to do at least 4 examples. For my first example, I decided to do 1 times 9 just because 1 times 9, of course, is 9, and that's the last digit you can display in hex. It'll be the same as in a regular decimal form before you get into A for 10. So we'll start with that one, 1 times 9. So here we have 1, and for a 9 we need a 1 and an 8. We also have this key here, and what this represents when we press this is a clock pulse. So when the clock pulses, we should get our result, and it's a little hard to see there, but you can see we got a 9. Okay, for my second one, I decided to do a 2 times 9. For a hexadecimal result, that'll yield a 12, a 1, 2. So we already have our 9 in this section. We'll set this section to a 2, so we get a 2 times 9 and a clock pulse. And as you can see, there's our hex result of 1, 2. For our next one, I decided to do a 5 times 9. We already have our 9 in this section, so we'll do our 5 over here, and for a 5 we'll have a 1 and a 4, which will give us 5. And for this one, we expect a result of 2, 0 in the hex form, which would be, of course, 45 in decimal. Or 2D, excuse me, 2D in hex form, which is a 45 in decimal. So we are getting the correct result there. And finally, I decided to do a big number so I could utilize all 3 of the segments just to show that they are all working. And for this one, I decided to do a 16 times 21. And 16 times 21, of course, in regular decimal will be 336, but in a hex representation, we should get a 150. So we need to set all these back to 0, and now we're going to do a 16. So there's our 16, and we're going to multiply that times 21. For 21, we need a 1, a 6, and a 4. So there's our 21, and then here's our 16. And we'll hit that, and we get the desired result, 150. So as you can see, everything's working like it should be. Thank you.